third problem of sliding on the pattern, and you can say the problem is nothing but longest k unique character substring. Okay, so basically, yeah, it has the playlist in the description. You can check it out, the whole playlist. Okay, so yeah, if you talk about this problem, so the statement is said that we are given a string and we just need to print the size of the longest possible substring. Okay, that has exactly k unique characters, and if there is no possible substring, then we just need to return -1 instead. Okay, so yeah, the basically what I need to do, we'll be given a string. You can say, you can just refer this example. You can say this is the given string. You can say, okay, so we'll be given a string and we also be given a k. Okay, so we just need to find the longest possible substring, okay, with maximum k distinct characters. So that is the thing. And if we just simply consider this example, so you can see this is the maximum possible substring we can achieve with with at most k distinct element. You can say k distinct characters. So you can say it has only c, b and e. These three are the unique characters. So the length is nothing but 7, and we just need to return the length of that. This is the very first example you can see, and we just have this string. Okay, and this k value is 3. What you need to do, we just need to find longest possible substring from this string, so that it at most can contain k unique characters. Okay, we can say, so you can say this will be the result. Okay, and the length is nothing but 7, so we just need to return 7. Okay, so that is the thing. Now let me tell you the approaches that we can follow to solve this approach. Okay, so first of all, we'll be talking about the very brute force approach, then we'll move towards the optimal solution. Okay, now if we talk about the brute force approach, then you can probably find a solution. Like, what I need to do, we just need to find the substring, right? So for substring, we can probably use nested loops to to find the substring, and every time we'll be checking that substring is contain only k unique characters or not. If that contains k unique characters, then we'll be having another variable that will be max length. We'll compare that with max length, and every time we'll be keep updating this max length if the current length is greater than max length, right? That will be the process. Okay, now let me show you what will be the process. Let's say we have for loop, nested for loop, we have an outer for loop. Okay, so for outer for loop, let's say point will be I. It will start from 0 and up to n, the length of the string. And we have another loop, for loop, that will be inner for loop, and let's say j will start from I. Okay, and it will also move up to n, the length of n. Then what I need to do, as we said, that we just need to keep counting the unique characters, so that we can maintain up to k unique characters, right? We just need to keep counting, keep maintaining. So for that reason, let's say we just need to have something to check whether the current character already exists or not. Okay, so for that we can use say data structure. So we have said data structure that only contains the unique elements or unique character, we can say. So with the help of this set data structure, we can track the unique characters, how much unique characters currently present in the current substring. Okay, so we can use that. Okay, so what we'll be doing, you can say I is here. Okay, I start from 0, j is also for the first iteration, j is here. So every time we just need to keep the current character, and we need to insert the current character into the into the say data structure. We just need to insert. Okay, insert. Okay, then we need to check the size. Okay, then we need to check the size of this say data structure, whether it exceed the length of k or not. Okay, now let me tell the process what I need to do. So first of all, you can say the j value is nothing but a, so we need to insert a. Then j will be here, so j is right now again a, so it will a, we inserted a and it will a. Okay, then j value is b, we need to insert b. So again is a, so we need to insert a, but this set data structure are already containing it, so we don't need to we don't need to insert this. Okay, then we have c, we need to insert c. Okay, this is c, not e. Okay, this is c. Then we are having b. Okay, so we already inserted b. Okay, so then we have e. Okay, so right now till now you can say the size is nothing but 3, so it does not exceed it the 3 length. So right now if we insert this e to this set data structure, so you can see right now the size is nothing but 4. Okay, so as we said, as a second operation, we need to check the size. It exceeds, right now you can say this is 4, so it exceeds the length k. Okay, so what I need to do, we need to simply check the length of this current subarray. So this subarray start from this I index, and this is the end index, so we can find this length. Okay, so that will be nothing but the difference between this. Okay, so nothing but this is j minus I. Okay, j minus I. So if we check the value of j pointer, so we can say this is 0, 1, 2, 3, 4, 5, 6. So we have basically 6 minus I pointer is 0, so basically we will be having 6. Okay, we just need to compare that current maximum value is less than this current length or not. If this current length is greater, then we need to just input that value. So you can say, as we said, that we just need to find the maximum length, so we'll initialize this with minimum value. Now we can say this 6 is greater than this, so we'll simply override this with 6. Okay, and yeah, that is the first thing. And then after that the inner loop will terminate here, then I will be here. Okay, then I'll be here, and again our, okay, let me erase that first. Okay, and again J will start from, I will be here at this position. Okay, not this position. Okay, and again J will start from a I position, and it goes toward this, and throughout this process we'll able to find the maximum length. Okay, so that is the brute force approach we can use, that can come to our mind, okay, very fast time. Okay, now if we talk about this time complexity, you can see we are using nested loop. Okay, so the time complexity will be nothing but big of n square for the nested loop. Okay, and we are also using this state data structure just to keep tracking the, unique elements. So that's why you can see this, this a data structure can have maximum k elements, or k plus 1 elements we can say. Okay, so for that reason our space complexity will be big of, we can say, k. Okay, so that is the time and space complexity for this. Let's talk about the optimal solution, and that will be nothing but sliding window approach. So we'll be using sliding window, and as you already know, sliding window means we just need to have a window. Okay, and based on the condition we just need to slide the window one step. Okay, one step. Okay, and we just need to shrink the window from the beginning. We just need to shrink the window from beginning, we can say, and we need to increase the size of the window from the, by just moving ahead. Okay, that is the thing. Okay, and we already know for the sliding window process what we just need to have something before starting. Okay, so for sliding window process we need to have start pointer. That will be nothing the start position of the sliding window, and we just need to keep okay, just let me write it here. We just need to use a for loop just to iterate through this string. Okay, and it will, let's say iterator will be I, it will start from 0. Okay, and it will, I will go up to the length. So we can say it will go up to the length, and every time I will increase by 1. Okay, so you can say this. Okay, that is the thing. And we need to perform the operation in between this for loop, we can say. Okay, in between this for loop. Okay, so what we'll be doing exactly? Okay, so basically okay, so we just need to return the maximum length. So we'll be taking a maximum length variable. Okay, and we just need to initialize this with minimum possible value, let's say minus infinite or minus 1, whatever according to you can take. Okay, okay, then what I need to do, we just need to, okay, we are done, but the thing is we also need to, keep tracking the unique characters. Okay, so that we can have maximum unique maximum this k size length of unique character. Okay, so for, to keep tracking the keep tracking the unique character, we'll be using a hash map. Okay, we'll be using hash map data structure. Okay, hash map data structure, and before that we already said that we use for the, brute force approach we use the hash set, not hash map, but for this approach we need to use hash map, not hash set. Okay, and I'll be explaining why we need to choose hash map instead of hash set. Okay, so we'll be having a hash set, you can say this is, let's say this is the hash set. Okay, and this will be nothing but which we will be storing a pair, and that will be character and the frequency of that character. Okay, that is the thing. So frequency will be of type integer. Okay, and character will be of type char. Okay, character type. Okay, now let me begin with the process. So right now you can say our, I'll start from here also. So right now what is the size of window? So you can say the size of window is nothing but 1. So this is only the window. Okay, okay, then what I need to do, again we need to do the same as we discussed in the brute force approach. Okay, we just need to insert this current character to this hash map. Okay, so first of all we have a, so this hash map is empty. So what I need to do, we need to insert a with its frequency. So right now frequency is 1. Okay, then okay, we just need to also, in between this we need to have some condition, like if we have, let's say we have the size of, anytime if we have the size of this hash map exactly equal to k. Okay, so we have, let's say if we have size that will be exactly equal to k. Okay, if this is equals to k, then what I need to do, we can say that we got a subarray. Okay, that contains this much or k unique characters. Okay, so in that case we can simply find the length. Okay, so we just need to find the length. Okay, so we just need to find we can say find length. Okay, we can say find length, we need to have find length. Okay, and we just need to compare with this maximum length. If the current length is greater than this maximum length, we just need to just override this maximum length with that current length. Okay, that we'll be doing. Okay, okay, now let me move the next step. So right now you can say the next element is again a. So what I need to do, we need to insert this a. So right now if we insert this a, the frequency will be 2. Okay, and then next we have b. Okay, then next we have b. So we just need to insert b with its frequency is nothing but 1. Okay, then next we have again a. Then we need to simply need to increase the frequency of a. You can say right now frequency is nothing but 3. Okay, now we have c. We need to input c with its frequency is 1. Okay, now we have b. We need to increase the frequency of b. So this is 2. Now we have e. Okay, so in that process you will be having, like in that process, okay, before this index we'll be having like size is nothing but what, size is nothing but 3. So we just need to check that what is the length. We just need to first find the length. So you can say for before that index, okay, let me erase that iteration. So before it was here, index I was here. So in that position we got size of this hash map equals to k. So in that position what will we doing, we just need to find the length. So you can say the length is nothing but j, the value of j index is 0 1 2 3 4 5. Okay, so we just need to find, if we want to find the find the length, then what you need to do, j minus I, and as this is a zero base index, so we need to add plus 1. So you can see the I value is nothing but 0, right? I value is nothing but 0. Okay, not I value, it will be start value, not I value, my bad. Okay, because I value is what, this is not I, this is a, we are using I pointer, right? Okay, so this is start, this is the start of the window. So you can say this is 0 right now, so we have 5 plus 1 is 6. So we just need to, as you can say, this is greater than this, so we just need to overwrite this maximum length with what, with 6. That is the thing. Okay, now let's move the next step. Okay, now I will be here. Okay, I will be here. Now you can say we just have e, so we need to insert e with its frequency 1. Okay, now in this position you can say the size is what, the size is equals to 4 and this exceed the length of k. Okay, so in that time what we need to do, we need to shrink the window, because we can have, okay, window can have maximum k unique elements, right? Maximum k unique elements, that we already said. Okay, so right now you can say that, you can say that our hash map containing 4 unique characters that exceed the length k. So we just need to, here we just need to apply a condition. Okay, and that will be nothing but while loop, and the condition will be if this size, okay, if this, okay, I'm using the short form s. Okay, if this size is greater than k, okay, greater than k, then we need to keep on reducing, we need to keep on shrinking the size of the window. Okay, we need to keep on shrinking the size of the window. So let's say here we need to reduce the size of the window. So what I need to do, if we want to reduce the size of the window, then we need to reduce from beginning. Okay, so this is the start point. Okay, let me erase this I pointer from here. So right now I pointer is here. Okay, so this is, you can say, the start pointer. This is a. So what if we want to shrink the shrink the window from beginning, then what I need to do, we need to delete, or we need to remove the start pointer character, right? So you can say the start pointer character, we need to remove the start pointer character. So we just need to write some logic here so that we can remove the start pointer. So it will be very basic. So first of all we need to find the character last, the begin start pointer character using string.char method. Okay, then we just need to delete or remove this character from the hash map. Okay, so you can say right now a is what, this is the start pointer value is a. So we just need to decrease, we just need to remove a, one a, right? Because we need to reduce the index frequency of us. So right now the frequency will be nothing but, let me erase that. So 3 minus 1, that will be nothing but 2. Okay, that will be the frequency, and we need to increase the start pointer. Right now start pointer will be here. Okay, start pointer will be at this position. Okay, so right now till you can say that right now also you can say that this size is still greater than greater than this 3. So again we need to perform the same, we need to delete this a also from this hash map. So if we again delete another a, so right now the frequency of a will be 1. Okay, so right now you can say still this size is greater than this 3. So again we need to again we need to what, again we need to remove this element, because that will be the second, that will be the starting pointer. So we need to delete b. So if we delete b, then we just need to have increase this, decrease this, so the frequency will be nothing but 1. Okay, let me do this in fresh. So the frequency will be 1 both places. Okay, this is 1, this is 1 also. Okay, now start pointer is here at a position. Okay, but you can still say that the length is greater than this 3. So again we need to remove the start pointer value. So right now start pointer is a, so we need to remove this a. Okay, and you can say the frequency of a is 1 right now. So if we simply remove this, so the frequency of a will be 0. That means what, that means we just need to remove the a from this hash map. Okay, okay, and again our start pointer will be here, but before that we just need to erase this. Okay, our index will be, our start pointer will be at this position. Okay, this is the start point, this is the start point. Okay, and right now you can say the the length of the the hash map is less than or equals to, you can say, not greater than this 3. So this will out of this while loop, and it will again control will again move towards the I. So right now I was here, right now I will be here. Okay, so you can say this is b, so we just need to insert this b. Right now if we insert this b, the in value of frequency of b will be 2. Okay, and again it's equal to the size of the size of 3, you can say. So this satisfy this condition. What I need to do, we need to find the length. So you can see what is the size right now, the right now the what, the index of I is nothing but 6. Okay, and minus the start index is 0 1 2 3 4. Okay, this is 4 plus 1, this will be the length. Now we can say this is nothing but 4 6, this is 2 plus 1, this is 3. Okay, so it does not greater than this length, so it will remain same, the length will remain 6. Okay, also. Okay, now let me just erase this. Okay, so now what I need to do, we need to again okay, we just need to check this. Okay, we already checked this. Then what I need to do, we need to check that is this satisfied. No, it does not satisfy. Then I will be here at this index, this e character. Okay, then we need to insert this e, so the frequency of u will be right now 2. Okay, so it's still the satisfying this condition, so the length now we just need to find the length. So you can see the length is nothing but plus 1, so it will be 4. Before that it was 3, so it will be 4, so it doesn't exceed this 6, so it will keep remain same. Okay, and it will move towards the b. Okay, then current element is b, so we need to increase the frequency of b with 3. So you can see it's still right now you can see this satisfying. So right now if we check the size will be nothing but 5, so it doesn't exceed the 6. So yeah, how much how the length will be 5, nothing but you can say the value of this I pointer is nothing but 0 1 2 3 4 5 6 7 8 9. This is 9, so we have 9 minus start pointer is 0 1 2 3 4 4. Okay, plus 1, so you can say 5 plus 1, this is 6, so it doesn't exceed this 6, so it will remain same. Okay, now let me erase this first. Okay, okay, again what I need to do, we need to, this does not exceed the size, so we are not going to enter into this loop. So again I will be at this position right now. Okay, now we need to insert this e, so right now it will be nothing but 3. Okay, okay, again this satisfies this condition, so we just need to check the length. So length will be nothing but you can say the index of I is nothing but 0 1 2 3 4 5 6 7 8 9 10. So this is nothing but 10, and the start position value is nothing but this, so this is 0 1 2 3 4, so 4. And we just need to add plus 1 for 0 base index. So right now we'll be having 6 plus 1, this will be 7. So this greater than this, so we just need to override this with 7. Okay, right now this 7, and you can see right now if we the control goes to I, and right now I will be here. Okay, so out of index you can say. So this loop will terminate here, this for loop will terminate here, and we just need to simply return whatever we get as maximum length. You can see the maximum length is 7, and we need to return this 7. Okay, that is the thing. Okay, that is the entire code that we explain. Okay, so right now if we talk about the time complexity, you can see this is, we are using only for loop just to iterate through the array. But if I talk about this while loop, okay, this can check, this can run only once for every element. Okay, so that's why it's not gonna take it's not gonna run n times, it's gonna run only one time. Okay, only one time. That's why we can say this is n times, and this can at most run one times. Okay, so that's why we can say the time complexity will be nothing but linear, that will be big of n. Okay, and if you talk about the space complexity, then yeah, exactly, we're using a hash map. Okay, that at most can contain k plus 1 elements, we can say k plus 1 elements, because we are handling this size with this while loop. Okay, because we are keep on reducing or keep on shrinking the size. Okay, when it exceed k plus k plus k, okay, size of k. So that's why you can say the length can have maximum, it can have maximum stored k elements. Okay, or k plus 1 element. So the space complexity will be nothing but k. Okay, big of k, you can say this will be nothing but big of k. Okay, so that is the whole process. So overall we can say this optimal solution is taking linear time complexity, that is big of n, and it's also taking the big of k space complexity. Okay, that is the overall thing. Now let's jump towards the code section so that we can code this approach. Now let's code the approach. Okay, so what I need to do, first of all, as we said, that we just need to have a variable just to keep counting the keep tracking the maximum length. Okay, so we'll be having an integer, let's say name will be max length. Okay, and we are going to initialize this with minus value. Why minus 1? Because you know that we just, if we are not if we are not find out any possible sub value, then we need to return minus 1. That's why as a default value we are taking minus 1. Okay, and what we need to do, we just need to have a start pointer. Okay, so let's say we have a start pointer that will start from 0. Okay, and that is the thing, and we need to iterate through the string, so we'll be using for loop. So here I will start from 0, and I will keep on moving up to the length of the string, that will be nothing but is dot length, and I'll increase 1 every time. Okay, now here what I need to do, every time we need to keep on inserting the current character to the hash map. That's why we also need to take the hash map first. Let's initialize the hash map. So we have a hash map. Okay, and okay, it will be a hash map, and the key will be nothing but character, and the value will be nothing but integer type. Okay, and let's say name is nothing but map is new hash map. Okay, we already initialized this. Now we can use this. So okay, we just need to, first of all we need to find the current character, and that will be nothing but char ch, let's say, and it will be is dot char at this current index that, and we need to insert this current character into the hash map. So how can do that? Okay, we can map dot put, we have put method to insert map dot put. We need to insert this character, and the thing is, if you already have this character, then what I need to do, we need to simply increase the frequency of that character. But if we don't have this character in the hash map, then we need to keep the frequency as one. So we'll be using a inbuilt method that will be map dot get or default, get or default. So basically it takes the key value, and that will be nothing but the character itself, and we are taking the default value as 0. Okay, and what I need to do, we need to increase the frequency plus 1. Okay, so this is the thing. Okay, so what I did here, basically, if we don't have, if the current character does not exist in this hash map, then it will return 0, and then we are adding plus 1, that will 0 plus 1 will be 1. And if the character is already present, then this will basically, this method get or default, okay, will return the character, return the frequency of this current key. Okay, that is the thing. Okay, we also already insert this. Then what I need to do, we need to check that if the map size, that means map dot with this size, if this map size is exactly equal to k, then what I need to do, we need to find the length. Let's say our length will be nothing but what the difference between the current index and start pointer. So this is nothing but I minus start pointer and plus 1 we need to do, because this is a 0 base index, and we need to keep the comparison between this length and max length. Okay, just to keep the maximum length. Okay, so max length, let's say, we'll be using math function. So math dot max of this max length and this current length. Okay, so yeah, that will be the thing, and that is the thing. If the size is exactly equal to the k, that we need to do. And we also need to check, okay, if this size is greater than k, then the condition will be what, if the size, that is map dot size, if this size is greater than k, then we need to shrink the window from beginning, right? So we need to shrink the window. So if we want to shrink the window, what do we need to do, we need to remove the start pointer character. So we just need to find a start character, or we can say left character. Let's say char will be, okay, char, let's say it's left, I'm taking the name as left. Okay, and it will be nothing but is dot uh, char at the start pointer position, and we need to simply delete this element, this character, from the hash map. So what we'll be doing, we just need to simply decrease the frequency of this character in the hash map. So we'll be using again put method. So map dot put, we will be putting this character with frequency minus 1. So we can find the frequency using get get method. So we'll be using map dot get, and then this current character. Okay, so we'll be, okay, my bad, this current character. So we just need to, we are getting this frequency, then we need to reduce the frequency. Okay, that is the thing. And we also also need to check if this frequency right now, okay, after reducing 1, if this becomes 0, then what I need to do, we need to remove that character. Okay, we need to remove that character from the hash map. Okay, so we just need to simply check if this frequency, I mean map dot get of left, uh, okay, let, if this frequency is equal 0, then we need to remove that. So map dot remove this left, I mean this character. Okay, that is the thing we need to do. And again, what I need to do, we need to increase the start pointer value by 1. Okay, and yeah, that is the thing we need to do in between this, inside this while loop, because this is nothing just to shrink the window size, so that we can we can optimize, or we can find the maximum length array. Okay, that is the thing. Okay, and after that, what I need to do, when we'll be out of this while loop, we just need to simply return the result, and that is nothing but max length. Okay, okay, that is the thing. Now let me run this code. Okay, so you can see it's working very well for these test cases. Now let me submit this code, so okay, we can check whether it's get submitted or not. Okay, okay, it's now checking against test cases, and it gets submitted, you can see. Okay, and that is the thing. Okay, and yeah, we already